All right, we are looking at a phase diagram here, and this is the general idea of what one looks like. This is a fictional substance. Every substance will have these general lines on a phase diagram, but they'll be at different temperatures and different pressures. So let's analyze this fictional substance. The idea is these represent the phases the substance can be in at equilibrium. So, for example, if a substance is very cold and under a lot of pressure, it is going to likely be a solid. So this is the solid region here. And if it's very hot and not under very much pressure, you're going to get a gas. And in between, we're going to get a liquid. So these are the three phases. Anyway, solids, liquids, gases. This is the general idea and shape. Along these lines, these are the boundaries. So a substance in this particular case, if it's at 200 degrees and about 1.2 atmospheres of pressure, it can exist as a solid or a liquid at this point, depending on how warm it is. So some things can exist in equilibrium. So for example, if you have ice water and it's at exactly 0 degrees Celsius at 1 atmosphere, the ice and water can coexist and they'll be stable for as long as need be. This point right here is known as the triple point, where all three phases can actually coexist under very kind of rare conditions. All right, so now what we look at is phase changes. So if you, or, all right, so again, so at 100 degrees and 1.5 atmospheres of pressure, a substance would be a solid. At 200 degrees, 1.5 atmospheres of pressure, still a solid. If you heat it to 300, now it's a liquid. So as I'm heating a substance at constant pressure, I'm passing from a solid to a liquid. So this is known as melting from a solid to a liquid. If, on the other hand, I had something at 400 degrees at 2 atmospheres and I started cooling it down, temperature's getting lower, becomes a solid, this would be freezing, right? From liquid to solid is freezing. If you have a liquid and you start heating it, and it becomes a gas, we know that is boiling. On the other hand, if you start cooling it, we know that is condensation. Now, what's interesting about this is there's more than one way to get a liquid to boil. Another way you can get a liquid to boil is instead of heating it, you just reduce the pressure. Maybe you put it in a vacuum. So the pressure gets lower and lower. It will eventually boil that way as well. So any crossing of the line from liquid to gas is boiling. Gas to liquid is going to be condensation. We can also go directly from solid to gas under certain conditions. Remember, this is sublimation, and we can go directly from gas to solid. That was deposition. So there's 6 different phase changes that can occur in this situation. Now, one thing you might be wondering is why this line ends. And so this is known as the critical point. And what the critical point is let's say that I have a gas that's really hot. Now, normally you can make a gas into a liquid by putting a lot of pressure on it. You force the molecules together and they liquefy. But a gas that's above this critical temperature, no matter how much pressure you put on it, it never actually liquefies. It's what's called a supercritical fluid. Now, usually the supercritical fluid region is thought to be sort of defined as this region here. But the idea is the only way you can get the gas to be a liquid is if you first cool it down to this boundary and then put it under pressure. So for example, hydrogen gas, no matter how much pressure you put hydrogen gas under, you cannot get it to liquefy at room temperature. It has too much energy. So you have to cool it down considerably first. So again, all these points are at different temperatures and pressures depending on the substance. This is not, necessarily a constant thing, but these are just the general properties and principles of this. Now, sometimes you will see something referred to as a normal boiling point or a normal melting point. Now, the idea is that this is again not water, but any substance can melt or boil at very different temperatures depending on the conditions. For example, this substance here at 1.5 atmospheres of pressure will melt at this point, which is roughly 230, 240 degrees Celsius. But if it's under greater pressure, say 2 atmospheres, it melts at just under 300 degrees Celsius. So depending on the pressure it's under, that will change the melting point. Likewise, the boiling point will change under different pressures. So when you see something about normal melting or normal boiling point, that refers to what we call normal conditions, which is typically 1 atmosphere. I mean, that's what normal means in this scenario. So the normal melting point of this substance, we look at 1 atmosphere, we come over to the boundary, and we say, okay, what temperature is that at? And we say roughly 160 degrees Celsius. That's the normal melting point. The normal boiling point is here at 1 atmosphere where it meets, and then come down here and about 330, 340 degrees Celsius. So just when you see normal melting or boiling point, just realize that we're looking at the boundary at 1 atmosphere. All right, one last thing I want to look at is the slope of this line. So most substances, almost all substances actually, as you put pressure on them, they become a solid. Most substances are most dense as a solid. For example, if you take candle wax and drop it into melted candle wax, the wax usually sinks, which is very different from water. If you take solid water, ice, and drop it into liquid, it actually just floats, which is really rare. We're used to seeing it, but that's not common of a solid to do. So the idea is normally as you put stuff under pressure, it actually becomes a solid. Water, on the other hand, is one of the few substances that the slope of this line actually goes backward, because as you put water under higher pressure, it will actually liquefy because it's more dense as a liquid than a solid. So whenever you put pressure on something, you're making it more dense in this case. And so a natural situation is as you put pressure on it, if it's more likely to become a solid, that's the standard way of things. If by putting more pressure on it, it starts to become a liquid, that's unique. Again, that's typically only water really does that. And again, if you ice skate at all, when you push down on your skates on the ice, you're actually melting a little bit of ice, and that's what lets you glide along a little bit more easily. So those are the major points of a phase diagram. And take the quiz on this, make sure you understand it. But that's about it. So until next time, I am Derek Genova. Have a delightful day.